All right, so let's do example 12. Example 12 says, find the element in the second row, second column of the following product of this product. Now, if you want an element in the second row, second column, you've got to multiply the second row of the first matrix by the second column in the second matrix in order to get the element that is in the second row, second column. So second row, so element, second row, second column. To get that, you'd have to multiply 3 minus 1, 2 by second row, second column by 2, 4, 2. You multiply a row by a column, so it's first element in the row, first element in the column. So this would be 3 2s 6. Minus 1, 4 times minus 4. Sorry, minus 1 times 4, minus 4. 2 times 2 is 4. And the answer is 6. Very quickly, let's talk about properties of matrix multiplication. So if A and B are, if A is conformable to B for matrix multiplication, B is not necessarily conformable to A for matrix multiplication. So generally, AB is not equal to BA. Let A, B, and C be conformal for matrix addition. Conformable for matrices, be conformable matrices for addition and multiplication. Then A, B plus A, B plus C is equal to AB plus AC. And A plus B, C is equal to AC plus BC. So in other words, multiplication distributes over addition for matrices. A, B, C is equal to A, B, C. So in other words, the multiplication of matrices is associative. Let's talk about the identity matrix. This says identity matrix, the leading diagonal is the diagonal from top left, from the top left corner to the bottom right corner of the matrix. So let I be the n by n identity matrix. Then AI is equal to IA is equal to A for any n by n matrix. Any n by n matrix A. So the identity matrix is a matrix whose leading diagonal consists of ones, and all other elements, leading diagonal elements consist of 1, and all other elements in the matrix are 0. So the 2 by 2 identity matrix is 1, 0, 0, 1. The 3 by 3 identity matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. The leading diagonal matrix, the leading diagonal in the matrix consists of ones, and all other elements are 0. If you multiply a matrix by the identity matrix, you're going to get back the original matrix, because multiplying by identity matrix is the equivalent of multiplying by 1. All right, so example 14, we're to find the matrix product. But what we're doing here is that we're multiplying a matrix, a 2 by 2 matrix, by the 2 by 2 identity matrix. So whenever you multiply a matrix by the identity matrix, you're going to get back the original matrix. So this would be 3, 2, 5, 4. You could do the multiplication if you want to, but I don't think it's necessary. If you multiply a matrix by the identity matrix, you're going to get back the original matrix, because multiplying by the identity matrix is the equivalent of multiplying a real number by 1. Multiplication of square matrices. We're asked to find a squared plus a plus 2i, where I is the 2 by 2 identity matrix. All right, so let's start by finding a squared. So a squared simply means a multiplied by a. 2 minus 1, 1, 1, multiplied by 2 minus 1, 1, 1. Multiply a row by a column. So 2 2's 4. 1 times minus 1, minus 1. 2 1's 2. 1 times 1 is 1. Bottom row, left column, minus 1 times 2 is minus 2. 1 times minus 1 is minus 1. Bottom row, right column, minus 1 times 1 is minus 1. And 1 times 1 is 1. So the answer here is 3, 3, minus 3, 0. So now let's find a squared plus a plus 2i. A squared, 3, 3 minus 3, 0, plus a, 2, 1, minus 1, 1, plus 2 times I, 1, 0, 0, 1. All right, so our answer, we have 3 plus 2 plus 2. We have 3 plus 1 plus 0. We have minus 3 minus 1 plus 0. We have 0 plus 1 plus 2. So the final answer here appears to be 7 minus 4, 4, 3. Moving on. All right, here we're asked to find, in example 16, we're asked to find a and a square, sorry, a square and a cube. So a square is a times a. Multiplying rows by columns. All right, so first row, left column, 0, 1, minus 1. Top row, middle column, 1, 1, 0. Top row, right column, minus 1, 1, minus 1. Middle row, left column, 0, 1, 1. Middle row, middle column, 0, 1, 0. Middle row, right column, 0, 1, 1. Bottom row, left column, 0, 0, 1. Bottom row, middle column, 0, 0, 0. Bottom row, right column, 0, 0, 1. So a square is 0, 2, minus 1, 2, 1, 2, 1, 0, 1. Now a cube would be a squared times a. A cube is a times a squared. So a cube is a times a squared. Times a squared. Let's multiply row by column. Top row, left column, 0, 2, minus 1. Top row, middle column, 2, 1, 0. Top row, right column, minus 1, 2, minus 1. Middle row, left column, 0, 0, 2, 1. Middle row, middle column, 0, 1, 0. Middle row, right column, 0, 2, 1. Bottom row, left column, 0, 0, 1. Bottom row, middle column, 2, 0, 0, 0, 0. Bottom row, right column, 0, 0, 1. So a cube would be equal to 1, 3, 0. 3, 1, 3. 1, 0, 1. Now we need 2a cube. We need 2a cube plus a square minus 1. All right. I don't think we have space for that, but let's try. 2a cube. It's 2 times a cube. plus a squared minus I. And this is the 3x3 identity. All right, so let's go. This is 2 plus 0 minus 1. 6 plus 2 minus 0. 0 minus 1 minus 0. 6 plus 2 minus 0. 2 plus 1 minus 1. 6 plus 2 minus 0. 2 plus 1 minus 0. 0 plus 0 minus 0. 2 plus 1 minus 1. So our final answer, 1, 8, minus 1, 8, 2, 8, 3, 0, 2. Moving on, example 17. All right, for example 17, the matrix D is 2, 0, 0, 2. We're asked to find D squared. Here's how I would probably handle this. D squared is actually, or D is actually 2, 1, 0, 0, 1. And D squared, so let's put D squared, multiplied by 2, 1, 0, 0, 1. 2 2s are 4. And when you multiply the I matrix by matrix, you get back the I matrix. So this is 1. You get back the matrix, 0, 0, 1. So for me, the answer here is 4, 0, 0, 4. I cube, so I cube would be, sorry, D cube would be D squared times D, or D times D squared. B, D cube is D times D squared. So this is 2, 1, 0, 0, 1, multiplied by 4, 0, 0, 4. This would be 2, 4, 0, 0, 4. So whenever you multiply a matrix by the I matrix, you get back the matrix. So multiplying every element inside by 2, we get 8, 0, 0, 8. All right, so deduce. So that is actually, now B, we're to deduce a matrix Dn. So D to the nth power, the way it looked to me is actually what? This is actually what? D squared is actually 2 square, 0, 0, 2 square. D cube is actually 2 cube, 0, 0, 2 cube. So d to the n would be 2 to the n, 0, 0, 2 to the n.